talked a little bit about some of the principles and some of the processes to go through developing all the aspects of the LID project. Now we're going to talk a little bit about some of the specific elements of the site assessment and layout. So one of the things that's specific to the type of development that we're doing is looking at a few of the main components. One of the key factors we talked about early was being able to reduce the development footprints, looking at some strategies for optimizing that. Road layout, the numbers that were thrown out of roads taking up to and more than 25% of communities make them a key player in reducing impacts, as well as being able to create opportunities for managing stormwater, so looking at road layout. Some of the things of building layout and placing buildings on the site itself, and then talking a little bit about open space, both as a strategy to incorporate into design as well as using it in stormwater management in that way. The concept that we're looking to minimize the disturbance when we actually look at optimizing the development footprint. So there's the examples of the lots where we've sort of maximized from lot line to lot line all of the development, and then the areas where we've actually sort of selectively placed buildings throughout the site. So there's some strategies to incorporate that, and the idea of looking at where you place lots in relationship to stormwater management. So looking at topography, looking at water flow through a site and being strategic about where that's happening. And then orientation of lot, both to functionally take advantage of some of those aspects, as well as that we're looking at making a good, marketable, saleable project. So taking advantage of views, taking advantage of movement and sequences through the site. So there's an aesthetic and cultural aspect to it as well. You know, all of these strategies, sort of from site scale to development to neighborhood to city, there's a lot of linking about, you know, where you can take advantage of particular strategies. So one of the things that we can incorporate LID throughout aspects of a larger site, but even looking at a lot line itself, you can take advantage of a lot of the aspects of low impact development. The diagram here shows a little bit of that in action. So reducing lot frontages, so moving the buildings closer to the adjacent roadway that reduces paving for driveways and so reduces overall impervious surface in that way. Reducing front yard setbacks, incorporating rain gardens and pervious pavement into drive aisles and pedestrian surfaces itself. Incorporating other aspects. Drought-tolerant plantings is one that reduces the overall impact and water use. Minimizing areas of lawn. It's one of those things where there's certain types of developments have certain expectations, so it doesn't necessarily say you can't have lawn or you can't have certain things, but fitting that to the aspects of the site design itself. So even on a site scale, there's opportunities, and that's actually a strategy on some projects is maybe the infrastructure and the overall layout will be in place to manage and take care of a certain amount of stormwater on a particular site, and then the builders, when they came in, there's a expectation that on each lot they have to manage a certain amount of impervious area in that way. So that's a strategy where you can, as maybe a multi-phase project goes in, the stormwater management gets built in phases that way. We talked a lot about roads and reducing the overall impact of a site design itself. One of the things we looked at was large lots start to limit the number of choices that you have on an overall site itself. So bigger lot sizes, you're sort of maximizing footprints, but there's still ways to integrate them in, even with a large lot format that incorporates maybe narrower roadway widths and maybe some of the stormwater management happening on the lots themselves. And this is sort of placed next to something more of like a cluster type development. If you look at the same site footprint and the same unit count or lot count, instead of a 7,000 or an 8,000 square foot lot going to a 4,000 square foot lot, clustering those in groups of developments, being able to incorporate those into localized stormwater management, say, similar to that example in these loops. The other opportunity is the ability to protect some of the native vegetation and soils, which maybe can be incorporated into dispersal, but also it creates more of a shared open space that can be used for stormwater management or an amenity in that way. And the overall impact of this between reduced roadway width and reduced lot size is you start having a significant minimized building footprint, which, when the example from earlier today, was a significant driver in overall cost savings by not having to manage as much of that stormwater. The analysis that can go into it can be relatively detailed. This is an example of a project in Bellingham where there was a lot of work went into finding the right fit between protection of the natural vegetation, the amount of open space versus the building area. And then there was a concern in this case of achieving adequate densities. They were like, I think there was a thought that there was going to have to be, taller buildings in order to meet the unit count on this project. So they went through a series of different iterations of site plans and sort of optimized on this site the heights of the buildings and the unit count and the mix. The take home of that is you obviously have to meet what the market is going to incorporate into a site, but there's a bunch of strategies to do that and still conserve and enhance a lot of the open space in that way. So a little bit more about roads. There's not a right answer to this. Each kind of strategy for incorporating types of development has pros and cons. So a grid layout, the impervious coverage is somewhere around 30%. It varies depending on the roadway width. One of the issues with this is if you do have a site that's maybe has some significant topography, has some site features, that a grid is a little less able to work around some of that stuff. You gotta, it's harder to manipulate in that way. One of the positives of this is because you have a lot of connectivity, it actually works really well for people being able to get around both as cars and pedestrians. So access is enhanced, whereas maybe adaptiveness to the site is not as good. A lot of the cul-de-sac type development, one of the things this does is maybe reduces the impervious coverage of the site because you have less roadway because you're not actually connecting roads through the site itself. And the other thing is being able to incorporate curvilinear road alignments maybe makes you able to adapt to topography or existing site features. The drawback of this is because of the lack of connections of streets and sidewalks is it's less connected for pedestrian environment. And that's sort of some of the criticism of modern cul-de-sac design is maybe efficient in some ways, but not necessarily the best environment for pedestrians. And then sort of a hybrid when you start looking at how do we protect significant amounts of open space, how do we reduce roadway width, and look for strategies to provide decentralized stormwater management throughout the site. So the road layout really provides the structure for how to do that. In this case, we're reducing the overall impervious coverage because of reduced roadway width, providing the loops that maybe can allay some of the fears of fire access, as well as providing good connectivity versus, say, cul-de-sacs. The ability to have the best of both worlds. You're not creating cul-de-sacs, but you're able to make curvilinear roads that are maybe more adapted to site features. You see in the little nodes in each of the loops, those are great opportunities for localized stormwater management that's distributed throughout the site. And then the connectivity itself is the key there, both as a roadway network and then through open space, using that as a pedestrian connectivity as well. The design of roadways, how narrow of a road can you go for service access and some of those things, but also looking at some of the things to think about parking, think about other aspects of road design, not just about stormwater management. But so one of the things that's really interesting and done a lot of streetscape integration of stormwater is there's sort of the multiple benefits of being able to layer traffic calming strategies like bulb outs with other stormwater management strategies. So you see this example, this is a project in Portland which was a retrofit of a residential street So these two planters were put at the downhill side of the end of the street, provide that traffic calming at the intersection, which creates a lower traffic speed and better crossing for the pedestrian, and also allows for the stormwater management at the end. And there's other strategies of being able to incorporate any of these bulb outs into the right-of-way. And the nice thing about it is when we start talking about doing this is there's still on-street parking opportunities, but you're sort of being strategic about how much roadway width and how much parking you need. The C Streets project in Seattle, where a narrower roadway width like this was created, but there's actually a little pocket periodically along the streetscape where there's parking for visitors. So rather than both sides of the street are just open in a sort of traditional format, we're still creating opportunities for that, but we're reducing the overall footprint. And then incorporating that into lots of different strategies such as roundabouts and other things. So that dual benefit of pedestrian traffic calming and stormwater. And then the streetscape itself, the idea of incorporating vegetation in a streetscape and street trees act as a buffer. The idea that if we're layering in stormwater into that, we're creating a way to enhance the streetscape experience itself, as well as create a visual and physical buffer between the actual pedestrians and the streetscape. So that's a strategy that good for livability, as well as one of the things we talk about is you're going to provide landscaping in the streetscape already. So if you can incorporate multiple functions into that, so we're already doing landscaping and street trees, so if we can incorporate stormwater, then we're not creating two different systems, we're creating that all in one individual system itself. So buildings are another aspect, reducing the overall building footprint itself, opportunities to build up. There's a market and there's a type of development, so sometimes people want single-family homes, other times there's a market and an opportunity to be able to build up, do multi-story and reduce the overall footprint of development, but keep the unit count the same. Looking at the topography of the site, being able to incorporate building along the axis of topographic lines rather than against them, so you're not doing as much cutting and filling, which is going to reduce the overall impact of the site. One of the things I've done a lot of is green roofs, and there's a lot of really great opportunities. Rooftops are one of the first place that water is falling on the site, so if you can manage rooftops using vegetated roofs, then that's an opportunity to turn something that's potentially a problem in stormwater that you're going to have to manage on the site somewhere, and you've eliminated that impervious area. And then a lot of strategies, depending on the site, using pen foundations and low impact foundations that can potentially reduce the amount of grading and the amount of impact on the site. Any of those strategies in combination, reducing that overall building footprint. We've talked a lot about open space as a strategy, both for increasing the amenity of a site as well as being able to potentially use it for dispersion, for stormwater management. This can be protecting existing vegetation on site as a way to minimize disturbance. It can also be creating more open space, even so if there wasn't anything there, integrating that into the design itself. So the way to do that, rather than the maximized footprint, is clustering, being able to minimize the building footprint and then maximize the open space itself. So site planning and how that's integrated into the site is an important aspect of that. There's a range of strategies, and some of it's going to be driven by what the code is telling you to do. Some of it's going to be driven by what the developer and your client or the type of development goals there are. But there's a lot of ways we can frame it in terms of a potential benefits that come out of this that can definitely have an impact on the bottom line. So the idea of, again, looking at strategies to make site spaces on the site multifunctional means that you're reducing, number one, the upfront costs, so you're not building things like multiple things that you need on site. So you can actually reduce the amount of development. So reducing the roadways means less pavement, which means less maintenance on that paving. Reducing the amount of gray infrastructure means less maintenance on that. So overall O&M costs can be significantly less. Reducing the storm drainage infrastructure has an upfront cost savings by not actually installing it in the first place, has an O&M cost by not having to maintain it long term. Reducing paving, I mentioned that as well. And then some of the things that maybe are a little harder to put an actual dollar sign on, but there's a lot of externalities or benefits beyond just being able to save money, save dollars. The ability to create niche industries, potentially jobs, so an economic benefit of the green industry. One example of that is there's a lot of businesses that 15 years ago didn't exist and now solely exist to design and install and maintain green roofs. So that's an industry that was built up based on new development, driving businesses to be able to take advantage of some of these strategies. And then a lot of the things that hopefully over time we'll start actually putting more dollar value on, but things like ecosystem services that start to, there's functions that are being provided by a lot of the things we're doing, and it's hard to put a dollar sign on it, but as we get better at doing that and being able to integrate that, then that's something that can add to the bottom line. So there's a tangible cost savings, and then there's some of these additional external cost savings that can happen as well.